Hello, today we are going to be talking about how you work through a projectile motion problem. These are things that are flying through the air in two directions, side to side and up and down. So the best way to learn about horizontal projectiles is just to start trying one. So here's how we would go through a problem like this. We've got Wile E. Coyote running off an 80-meter high cliff at a speed of 18 meters per second. And we want to know how long is he in the air and how far away from the base of the cliff does he land. The first thing you're going to want to do is draw a picture of it. It's best when you can visualize exactly what is happening. So this picture won't be to any kind of scale, but here is my cliff that is 80 meters tall. So I'm just going to throw that in there. Wile E. Coyote, I'm not an artist, so he is a circle here, and he is running off this cliff with a speed of 18 meters per second. So I'm going to put all of that information in there. Now, Wile E. Coyote's motion is different for horizontal and vertical. We can split this into how is he moving horizontally in the x direction and vertically in the y direction, because gravity doesn't affect your horizontal movement. So I'm going to take all of the things that I know and split it into x and y. So like when we use the guess strategy, the givens, unknowns, equation, substitute, solve, I'm going to start by what are my givens in the x. So here is the x direction. And what do I know? I know his initial velocity is 18 meters per second. I don't know how far he travels. I don't know how long he's traveling for. So I can say the distance is a question mark and the time is a question mark. In the x direction, there is no acceleration. Gravity does not pull you side to side, it pulls you down. So there is no acceleration in the x direction. Now I want to look at the y direction. And again, I'm going to write down everything I know. Now I'm going to pretend instead of running off this cliff, he just falls off. It is like an object in free fall. Like the bullet fired versus bullet dropped from Mythbusters, we saw that an object that is flying off of a cliff like this, or a bullet flying out of a gun, falls the same way as one that is dropped. So my initial velocity in the y direction is just like if Wile E. Coyote fell off this cliff, and my initial velocity is 0 meters per second, just like an object in free fall. Since we're in free fall and we've got gravity, I know that the acceleration due to gravity is negative 9.8 meters per second squared. There are still a couple things that I don't know. I don't know his final velocity. I do know the distance, whether he goes in an arcing path or if he falls straight down. Wile E. Coyote is going to go vertically 80 meters. No matter which way he falls, flying off the cliff or just jumping straight down, he is going to fall 80 meters. And the last piece of information is I don't know the time. But like the bullet fired versus the bullet dropped, the x direction time and the y direction time are going to be the same. That is the one piece of information that they share. It takes the same amount of time for Wile E. Coyote to just drop down the cliff as it takes for him to fly off and hit the ground this way. So the time will match up between them both. So I've got a lot of information written on the paper now. Let's go back and look at what does the question want. The first question, the first thing is, how long is Wile E. Coyote in the air? So that is going to be my time. I'm going to start by looking for t. Now, if I tried to find time in the x direction, I've got one thing that I do know and two things that I don't. There's an equation that I can use. Velocity is distance over time, but I don't know distance or time. So this isn't going to be super helpful to me. If I look in the y direction, though, there are 5 things. I don't know 2 of them. But right now, I don't care about final velocity. It does not ask me for final velocity. And like an object in free fall, I've got an equation I can use for when I don't know about final velocity that I can use to find the time. So I'm going to use my equation number 5 from the equation sheet to find the time it takes Wile E. Coyote to fall. So I've got the distance is equal to the initial velocity times time plus 1/2 AT squared. What's going to be tricky about these kinds of problems is keeping track of what variables and in what direction I'm moving. Since I've got an A, this can only be y direction, so I am only going to use variables and numbers from my y direction information. So distance here is 80, is going to be equal to my initial velocity is 0. My time is what I'm solving for. 1/2 A is 9.8. And time is again what I'm solving for. 0 times t is just 0. So I can say 80 is equal to 1/2 times 9.8 is 4.9 t squared. Pull out my calculator and see that 80 divided by 4.9 is 16.3, which is t squared. So then I just need to find the square root of 16.3 to get t, and I found that it was 4.04 is equal to t. Remember, the time it takes to just fall straight down is the same amount of time it takes to hit the ground, even if I'm taking this curved path. So 4.04 seconds is my y direction time, and it is my x direction time. That is the one value that they share. So I found the time it takes Wile to hit the ground. I'm not done quite yet. Now it wants to know how far away from the base of the cliff does Wile E. Coyote land. Now I care about how far from the base of the cliff. That is this distance. That is in the x direction. This is my x direction distance, which means I'm going to use my x direction information to find it. So I am looking for x direction distance, and I'm going to use the equation from before, v equals d over t, or we can rearrange this. It is the same as saying distance equals velocity over time. I know my velocity is 18. I know my time is 4.04. Now I just need to divide. So 18 divided by 4.04 is 4.46 meters. So I find the distance to be 4.46 meters. That is the first example of how you can solve a horizontal projectile project, That is the first example of how you can solve a horizontal projectile problem. If I flip over to the back, I've got another example for you. So now I've got a physics student rolling a ball off of the top of a lab table, and it falls off the table with a horizontal velocity of 15 meters per second. If it takes the ball 1.34 seconds to hit the ground, how high was the lab table, and how far away from the lab table did the ball land? One strategy that some people find useful, this is not a strategy you have to use, but it is something that some people find useful, is to color code the information. So I'm going to draw my picture and then color code everything that I've got. Again, this is not to scale. Here's my beautiful table, and it does not tell me the height of the lab table. I don't know how tall that is. But here's the ball that is rolling off the lab table, and it has a velocity of 15 meters per second. It's going to follow some curved path, and I just write it off to the side that the time is 1.34 seconds. So now I'm going to go through, and when I write all of my information, I'm going to color code it. So it falls off the table with a horizontal velocity of 15 meters per second. So my x direction, or my horizontal information, I'm going to have in red, and I know that my velocity is 15 meters per second. I don't know the distance, but I do know the time. It is 1.34 seconds. Now I'm going to switch colors to get some information about the vertical movement, the Y direction movement. That will be in blue. And remember, the one piece of information that they share is this time. So the time in the Y direction is also 1.34 seconds. Since this is the same as if the ball just dropped straight to the ground, I know that the initial velocity is 0 meters per second. I know that the acceleration is the acceleration due to gravity of negative 9.8 meters per second squared. I do not know the final velocity, and I do not know the distance. So now I've got all of my information in 2 different colors. Maybe that is helpful for keeping track of what's going on. So the first question I've got, how high was the lab table? The height of the lab table is my distance in the Y direction. So I'm looking for blue distance, or the Y direction distance. I'm going to go back. This part, remember, is as if the ball was just falling straight down, an object in free fall. So I'll go back to my equation chart. I don't know final velocity, and right now I don't care about final velocity. So I'm going to use the same equation as last time, this number 5 equation, and I've got that the distance is equal to the initial t plus 1/2 at squared. I'm going to go ahead and switch to a pencil just so that I can easily erase any mistakes. I don't know the distance. My initial velocity is 0. My time is 1.34 plus 1/2. A is always 9.8 in free fall, and t is still 1.34. Now it's squared. So I've got the distance is equal to 0 plus 1/2 times 9.8 times 1.34 squared, which is 1.7956. Go ahead and multiply all of the things that I have together, and I get that the distance is 8.80 meters. This is, remember, the height of the lab table. I'm working in the Y direction, so a distance in the Y direction is up and down, the height of this table. Next, it asks me, how far away from the lab table did the ball land? Now I want to know how far from the lab table. This is another distance. Sometimes people will mark a little dx and a little dy to keep those separated so they know which one is which. Some color code, whatever system works for you. But now I'm looking for the horizontal distance. This one, I've already got time, I've already got velocity. It is the same equation as before. Distance equals velocity over time. Plug in my velocity and my time, 15 and 1.34. Then I can do 15 divided by 1.34 to find that the horizontal distance is 11.19 meters. That is how far from the base of the lab table the ball will land. So when you are doing horizontal projectile problems, the biggest thing is splitting your information into the X information and the Y information. X, there is not any acceleration. You only have a velocity, a distance, and a time. In the Y direction, it is the same as we've been doing, as if the object was just falling straight down, an object in free fall. So the initial velocity will be 0, the acceleration will be due to gravity, 9.8, unless it's on the moon or something, and then you'll have time, final velocity, and displacement or distance. That could also come up. Drawing a picture really helps to keep all of these pieces together in your brain and understand exactly how the stuff is moving. And I recommend using colors or columns or subscripts like these to help keep the information separate so you know which pieces you are working with at which times. And that is how you solve a horizontal projectile problem. We're going to be doing lots of practice with this and in a couple different ways over the next class periods.